Hi, I'm Tim Meehan, chair of the Presto Foundation, TSC, and also software engineer at IBM, here to talk about Presto. Um, so, I think this is a fairly technical crowd, so I'm not going to go too much into the details about what is Presto. I'll go over some highlights though. Presto is an interactive query engine. It can also do batch, which I'll get to in a second. Has a very flexible architecture that allows you to configure it for multiple environments and pull in data from multiple sources. So it was developed early on at Facebook, now Meta, both for querying its gigantic lake and also for interactive, sort of like batch, data applications, dashboards, all sorts of stuff. So it's kind of like a one-stop shop over there for interacting with the lake. And that's also kind of like the how most folks use it. The common thread is that it's typically used in front of the lake, and so most of the R&D is kind of like spent making the lake experience really great. So just a few key features. Presto is designed for really good performance and low latency. It has two runtimes. What first is kind of like a traditional MPP based runtime. So that's optimized to reduce latency and make sure that you get the time to first byte and results really quickly. And that gives it the kind of like interactive feel. And the second is a Spark based runtime, which gives it robust scaling and fault tolerance for large batch workloads. Presto has been used at hyperscalers for a very long time, so we know that it scales, very well up to thousands of nodes. And for that same reason, it's also typically highly reliable, just because we get a ton of production workload that sits in front of it, and bugs are surfaced pretty quickly. So I'll shift gears a little bit and just talk about some of the features that we love about Iceberg. I think we talked about some of this, but I'm just going to type to Presto specifically in a second, so please bear with me. You read through Iceberg's, features, and it really just kind of like reads like a rap sheet about what Hive doesn't what Hive doesn't do. And so, like, we really love Iceberg at Presto because it just makes the things that we work on, which is querying over the lake, really that much better. And just it's just an order of magnitude improvement over the Hive experience. So, like the first thing is, Iceberg ensures that when changes are made, there's a consistent timeline. Nothing conflicts with each other. You get the safety on a lake, which is exactly where you'd expect conflicts and stuff to override each other. So, it just kind of like makes things play nicely over the lake. Your metadata is now scalable. So you no longer have to kind of like spend a lot of time tweaking your MySQL database that's behind the HMS. It just puts the metadata inside cloud storage, and you're really good to go. So it just makes your data infrastructure a lot less hands-on, at least in that one specific way. So speaking of the Hive Metastore, you now have options other than the Hive Metastore, which is really great because like you have alternative cataloging tools that you can use to maintain, kind of like the catalog of tables that you have for your lake. And there's, I think like a set of growing options that are, really appealing now, besides the Hive Metastore. So storage is separated from the queries in Iceberg, which lets you decouple the partitioning from your queries. So you don't need to kind of like specify a partitioning key. You can have this hidden partitioning feature, which is really powerful and very easy to use. And so it just puts less cognitive load on the people authoring the query, which is awesome. Schema evolution is a lot cheaper, and writing data is a lot cheaper. So you can kind of like make these small incremental updates and not have to rewrite everything, which is really a game changer. And so like at Presto, we've been hard at work. Really excited to share some of the things that we've worked on over the past few months. So the first is kind of like syntax level time travel in Presto. That's kind of like a something that's built in. We had kind of like a stored procedure way of going about this before, but now it's a first class citizen. We are doing a much better job of extracting the query's predicates, pushing them down into Iceberg, and then kind of like reducing work where possible. Where sort of like if something was fully pushed down into kind of like the scan planning phase, then you can, Oh, okay, got it. Thank you. Um, now we're up to date. Thanks for pointing that out. So moving on, like we now support multiple catalogs, Hive Metastore, Glue, Nessie, Hadoop. and pretty soon we'll have the JDBC and REST catalogs. And you also have, like support for hidden partitioning now in Presto, so you can alter tables to kind of like make these updates. And then also, when you create the table, you can specify the partitioning functions in Iceberg, and the library sort of just takes care of it. We do support, like schema evolution. This is kind of like mostly for free, thanks to Iceberg. And also, we now support positional deletes in Presto. We're also working on this in C++, which I'll get to in a second. So I think one of the things I wanted to mention is that like we're talking about like the lake house, and these days we're calling it the lake house, but we were working on that before people kind of like had that name for it. So the first thing that we need, we noticed at Presto was that you need robust end-to-end caching in order to not have to use a different system. So if you don't do this robust end-to-end caching, then what you have to do is you have to kind of like re-ETL it into a system that kind of like materializes the data, and that's expensive. So like one of the things that we started to do even before the Lakehouse paper was basically just kind of like bring the support into Presto. Um, and by the way, like what we mean by end-to-end caching is just kind of like everything. So the data files, the org footers, the metadata, trying to get that kind of like fully integrated into Presto. The way that Iceberg makes this a lot nicer is that cache invalidation is just a whole lot simpler and easy to use. So you don't need, I think like one of the downsides of using caching in Hive is that you need a TTL. And so like that really breaks, of course there's no ACID, consistency, but it just breaks the user experience in Hive and makes that very cumbersome. So this is a very nice thing that just, like we kind of like almost get for free just due to how Iceberg works. Oh, let me go back. So scan planning, I think like the specific way that this helps moves Presto and other engines toward the lakehouse vision is that you can compact the data files to support fast queries. And so like this really helps you to at the table level figure out which tables need to be sorted or z ordered to support really fast queries. And so like having that flexibility in Iceberg kind of like is key to not having to use a different system. Statistics. So one of the great things about Iceberg is that in order to support scan planning, you need detailed statistics. And so like these statistics are also used by the cost-based optimizer, and having the statistics in Iceberg, like there's just a higher chance that you're actually going to have these statistics. And so, this helps the optimizer make better choices and just, makes it, faster by default. So a few others. There's multi-tenancy. So batch and table maintenance can be done safely now, thanks to the Iceberg spec. Openness. I think like this also kind of like goes to the spec, but having an open spec, it just makes it so that you get a consistent experience. Like when you have to move to a query, like a query tool from your batch tool, and then like this. I feel like this kind of like commoditizes some of the special features that used to kind of like be handled on a one-off basis, which is really awesome. So, right. So, like we talked about what makes Iceberg awesome, and we talked about some of the recent support added in Presto to support it. I think like higher level, one of the things that I think the Iceberg community does really well is the mindset that it adopts as to kind of like what responsibilities belong where in the modern data infrastructure. And so like by considering the lower, half of your database, to be, kind of like have a consistent behavior, have a, spec that essentially every query, query engine must follow. This is really powerful. Sort of like this essentially kind of like goes back into the commoditization where it just makes it so that the user experience is consistent as you kind of like go from tools to engines and what have you. And so like this basically reminds me of what we're working on with Presto, which is we want to be the premier data lake engine. And so that doesn't only mean That doesn't mean the only data lake engine, but essentially the tool that you reach to first, when you have one. And so I think that the Iceberg brings to the table is that it tells engines what the rules are and kind of like allows the engines to focus on the things that they want to focus on. And for Presto, that's speed. We want Presto to replace your data warehouse appliances. And so, what does it take to do that? So here, like I'll go over kind of like the Lakehouse paper. Has anyone read the Lakehouse paper from 2021? A few hands. So, like the gist of it is that you get this shocking result, which is that if you use this modern table format, you get a lot of what the data warehouses offer, kind of like for free. And so, like that's a little bit unexpected, and it's has profound implications. Like essentially, you ask why do you need a data warehouse often? And so let's go back to how they came to this shocking result. The first was that they added robust caching. So we talked about that. And so, like, we observed the same thing. If you don't add the caching, then you need a different tool. That's essentially, kind of like the gist of that. They added statistics to support, advanced scan planning and a robust cost-based optimizer. So without the statistics, okay, I'm getting a time check. Um, like it's very difficult to kind of like get data warehouse like performance. And then finally, they optimize the data layout of the files themselves. So sorting, z-order really make work more productive for individual splits, and you end up having to shuffle less. But that's not all. And so like really, and here's kind of like the end to end, but really, kind of like what does it take to get a performant engine that can actually compete with a data warehouse? The first is that you need a mature optimizer. So like we've been working on some of this. Obviously, this is optimizers are a very long established field, but we're working on basically kind of like improving this through constraint support, is expanding the search space, and then adding a historical statistics to influence cost-based decisions. You need to make sure that planning doesn't get in the way, and then the final thing that you need is a state-of-the-art execution. So like you need techniques like vectorized execution, adaptive algorithms, for core operators, and then efficient use of memory. And it's just difficult to kind of like get the performance that you need to replace your data warehouse if you're using Java. So that's exactly what we're working on. Like we're actually working on. We'll have support for Iceberg by the end of Q2, and really excited to share that we do have like a really great performance from that. Obviously, per Jason's talk, it's important not to do dumb things, prior to that, but for the vast majority of your workload, like it's barring that, you want to make sure that your execution is sound for all those unoptimized queries as well. So that's it.